Okay, last topic for this unit is identifying limiting reactant and calculating excess reactant. Okay, let's start from one daily life example so that will be easy for everyone. So here we are going to make one cheese sandwich. This is the recipe. So it says we need 2 bread, 1 meat and 1 cheese to make one sandwich. So if you are trying to make sandwiches and I gave you 7 pieces of bread, 3 pieces of meat, 2 pieces of cheese, how many sandwiches you will be able to make? So you have this time you have 7 bread, 3 pieces of meat and 2 cheese. How many sandwiches you can make? Okay, so you have to think. We know that 7 breads you can make 3 sandwiches. With 3 meat you can make 3 sandwich and 2 cheese you can make 1 sandwich if all other ingredients are same are excess. Okay, so here since you have only 2 cheeses you can make only 2 sandwiches. So you will use 2 cheese for that. We need only 2 meats and we need only 4 bread. Everything will be excess. So basically you can make only 2 sandwiches from the given ingredients because we don't have enough amount of the other one. So which item we are completely using or which item is completely run out first? So which is cheese? So cheese limits the amount of sandwiches we can say that is your product you can make. So that is the factor limiting the amount. Okay, so that limiting factor we are going to call with another name which is called limiting reactant. Let's see one chemistry example. Okay, here you can see 2 hydrogen because they are diatomic, 1 oxygen, it is also diatomic, and you are getting 2 Mickey Mouses. No, 2 moles of water. Okay, so that is the mole ratio. You need 2 and there is nothing. That means you need 1 of this and that will produce 2 moles. The scenario, if you have 2 hydrogen and 1 oxygen, you can make 2 water. If there are 4 molecules of hydrogen, that means this time you have 4 and 3 molecules of water, 3 molecules of oxygen, how many molecules of water you can make? Okay, think if you have 4, they are in the same ratio, so if they are 4 you can make 4. If there are 3 oxygen you can make 6. So we don't have enough hydrogen, so you can make only how many? You can make only 4 water. Which reactant is runs out first? We know that hydrogen is the one runs out first, so we can say hydrogen, which is H2, is the one limiting the amount of water. So hydrogen is the limiting reactant in this scenario. And the other one, which is oxygen, that will be there in excess. There will be little bit of oxygen left over there. Okay, that is a concept. Now we are going to do the practices and see how we can use dimensional analysis to find the limiting reactant and identify the limiting reactant and calculate the excess reactants. Okay. So the definition of limiting reactant is which controls the product. It is completely used up and which always give the least amount of product, and we will call that least amount of product with a name which is the actual theoretical yield. Okay, the abbreviation we are going to use throughout limiting reactant, we will write ALR. Theoretical yield, we will write TY. Okay, let's do it. This time you have a question. According to the equation, there is 2 mole plus 1 mole giving 2 mole. You have given 4 moles of Na and 4 moles of chlorine, and you are going to find what is your limiting reactant and how much product you can make. Okay, so we know that there is 2 moles of sodium will give 2 moles of sodium chloride, and 1 moles of chlorine will give 2 moles of sodium chloride. So those are the mole ratio. Let's go ahead and start the T chart from the given. So you will do 2 T chart for all limiting reactant based on how many reactants given. So there is a reactant 1 which is sodium 4 moles, and we know that 2 moles of sodium will produce 2 moles of sodium chloride. So basically you can make 4 moles of NaCl. And chlorine, 1 mole of chlorine will produce 2 moles, so you can make 8 moles of sodium chloride. So which reactant gave you the least amount of product? That is the limiting reactant. Let's go ahead and see. This one gives you only 4 mole. So we will call that is your theoretical yield. We can only produce this much even though the second reactant is showing 8 moles. So reason this one runs out first, so we will call that one a limiting reactant. So limiting reactant is the one will always give you least amount of product. Okay, and this will be there in excess. That is the excess reactant. Okay, go down right. Sodium will completely consumed first. Sodium is the limiting reactant because it produce the least amount of product. Or you can say that completely consumed. I can't write. Completely consumed or runs out first. Okay, and we also already said that the least amount is called the theoretical yield. Okay, now let's do an actual question. There are questions mole to mole, gram to mole, mole to gram. Remember, identifying limiting reactant easy way doing mole to mole, but you can go till gram or you can go till particles. That's up to you or based on the question. So this one, it says already moles is given. Okay, even though gram is also given. Moles of salt. Salt is this. Salt is NaCl. Okay, you need to make that much. So question says you need 0.5 mole of NaCl and you have zero point 0.4 mole of sodium and 0.25 mole of chlorine. Question, can I make what I need? Okay, let's go and start a T chart. You can do other way, but T chart is needed. So we'll start we will start from the reactant one, which is sodium. So 0.4 moles of sodium. And according to the equation, 2 mole of sodium will give 2 mole of NaCl. 2 and 2 will cancel, and you will get 0.4 mole, 0.4 moles of NaCl. Okay. Now let's start from reactant 2, which is 0.25 mole of chlorine. And we know that 1 mole of chlorine will produce 2 mole of NaCl. And you will get 0.5 mole of NaCl. Okay, now let's see. This is the lowest amount of product. So we can only make this much. That is your theoretical yield. Reason sodium chloride. Sodium is the limiting reactant which runs out first. Okay. So can I make what I need? You have to answer the question. You have to say no, because sodium runs out before that. You can make only how much? 0.4. Okay, now let's do the next question. This question says moles to gram conversion, okay? And it has two ingredients, two reactants, both are in gram. You are going to find how much NaCl can be produced. So, if it is how much and it doesn't specify anything, I will always go find the value in gram, because how much is in gram. Okay, or you can stop that in moles. Since question doesn't specify in gram, you can stop that there also. Okay, let's see both ways. Okay, let's start from reactant 1. Okay, start the T chart, which is 45.2 grams of sodium, and you will write the molar mass of sodium is 22.99 gram of sodium, which is 1 mole of sodium. Okay, now we have to find the mole ratio. We know that 2 mole of sodium will produce 2 mole of sodium chloride, and you will get 1.85 moles of NaCl. Okay, now let's start from reactant 2, which is 32.6 gram of chlorine. Okay, we know that chlorine, which is diatomic, you have to multiply 790 grams of chlorine is 1 mole of chlorine. Okay, then 1 mole of chlorine will give 2 mole of NaCl, which is 0.918 mole of NaCl. Now look at the value, which is the lowest value. This is the lowest value. So that is your theoretical yield. So your theoretical yield, this is the theoretical yield, Ty. And this one is the limiting reactant. So now let's go ahead and find how much gram of that will be produced. So you can continue this 1 to gram. It's up to you, or just pick the theoretical yield I'm gonna write 0.8918 moles of NaCl, and 1 mole of NaCl is, I think it is 58.44 gram of NaCl. That is the mass you will get in gram. 585 grams of NaCl. So that is the final answer for that question. Okay, let's go. Okay, this is the same question. If I want to do it, you can do it, or I'm gonna do one practice. I think that is like a step by step. We can calculate excess reactant, limiting reactant, so you will get all the practice there. Okay, let's do that. Okay, first, balance equation as always. See, there is 3, 2. Okay, we balance equation. Now you have two reactant. This is reactant 1 and this is reactant 2, and the first question is asking identify the limiting reactant. So we are going to start 2T chart. Start from 3.2 gram of aluminum, and we know that 26.98 gram of aluminum is 1 mole of aluminum, and we know that 2 mole of aluminum will give 2 mole of aluminum chloride, okay, which is 0.12 mole of aluminum chloride. Okay, start from the reactant 2, which is 5.4 gram of chlorine, and again 70.90 grams of chlorine is 1 mole of chlorine, and we need 3 mole of chlorine. 3 mole of chlorine is giving 2 mole of aluminum chloride. Okay, now you do the calculation, you will get 0.05 moles of aluminum chloride. Okay, now see the answers. Which one is the lowest amount? This is the lowest amount. That means whatever the reactant gave you, the lowest amount is what? That is the limiting reactant, and this is your theoretical yield mode. So your limiting reactant is chlorine. Okay, now how many grams of product? Okay, then now you need to continue that. It said you can do that in first step, but if you want to continue, just continue from the theoretical yield. We already have the mole value there. So you will write 0.05 moles of aluminum chloride. Okay, and write the molar mass of aluminum chloride. Find it. 1 mole of aluminum chloride is equal to how much gram? The 133.33 gram, I believe. I don't know. Just check it. Okay, let's do. Then you will get the answer. Okay, so I think we need 1 second. Let me calculate that. There is a sigfig missing on the previous one. 5.4 times 2 divided by 70.90 divided by 3. Okay, so here I had to add 1 here because it is 2 sigfigs. Okay, messed up on that, so we need 2 sigfig here too. Okay, so which is let me calculate it. 26.98 plus 70.90 plus 35.45, 133.33 times 0.51, which is 6.79, and your answer is 6.8 grams of aluminum chloride. So that is the amount in grams. So this is the theoretical yield in gram. Okay, now for calculating excess reactant, there are two ways to do. You can start from the theoretical yield and find how much the other reactant is needed. But I will prefer you guys start from the limiting reactant, because in case you messed up on your answer, you will lose all the points. Okay, start from limiting reactant to find excess reactant. Okay, so we are going to start the T chart from the limiting reactant, which is 5.4 gram of chlorine, and you can use all the values from the previous. 1 mole of chlorine, and the balance equation says 3 mole of chlorine needed 2 mole of aluminum, and we are continuing because it is mass, so it is easy to continue one more step. 1 mole of aluminum is 26.98 gram of aluminum. Let me calculate that. So that is you will get 1.4 grams of aluminum. Okay, so this is the amount used or needed to make that much product. So to find the excess reactant, we will use the given minus used. So the given of aluminum is 3.2 gram. 3.2 gram minus 1.4 gram will be 1.8 gram of aluminum will be in excess. Okay, that's how we are doing it. I already did one practice for you, and let's continue like that, and do all the practice